Hi everyone, welcome to LearnNCode. In the last presentation, we have started the topic called arithmetic operators in Python. After completing the operators, next we have discussed the terms precedence and associativity. Next, in today's session, we are going to talk about the remaining operators. Let us first discuss the relational operators, or we can say the comparison operators. After that, we will discuss the logical operators, bitwise operators, and assignment operators one by one. Let us discuss first comparison operators, or we can say relational operators. Let us discuss the relational operators. As I said that relational operators are also known as comparison operators. Comparison operators. After this, now we will talk about the types of relational operators. How many types are there? There are 6 types of operators, comparison operators. The first one we are going to discuss is greater than. Greater than operator. It is denoted by like this, greater than symbol. And second one is less than. Less than symbol. It is denoted by this symbol. And third one we are talking about is greater than or equal to, or we can say equals to. This is the symbol for this. And fourth one we are discussing is less than or equals to. Less than or equal to, or we can say equals to. This is the symbol. And fifth one is equal to or equals to. This is the symbol, double assignment operator, right? Now sixth one is not equal to. Not equals to or equal to. This is the symbol. These are 6 types of relational operators or comparison operators. This is a symbol for greater than, and this is a symbol for less than, and this is a symbol for greater than or equals to. This is less than or equals to. This is equals to, and this is not equals to. We will see these operators one by one with an example. Let us discuss. Now we are going to discuss the first one, that is called greater than. The operator is greater than. Let us take some example. Here I am taking 10. 10 is greater than 2. In this is the first operand. We call it as operand 1, and this is operand 2. In the last session, we have discussed about what is meant by operator and what is an operand. An expression is the collection of operands and operators. 10 is greater than 2. This is one expression where the first operand is 10 and second operand is 2. Between the operand 10 and 2, we are applying the operator, relational operator greater than or comparison operator greater than. When 10 is greater than 2, is the condition is true? Right, it is true. When it is true, when the first operand is greater than second operand, now the operator greater than is going to return the value true. If it is not greater than 2, for example, if I take 2 is greater than 10, in this case, the first operand is not greater than 10. It is not true. In this case, it is going to return the Boolean value called false. Mainly, the comparison operators or the relational operators are going to give the result in the form of true or false. Right? That is very, very important. Now, coming to the second one, less than. When you take less than, for example, here I am writing 2 is less than 10. Is 2 is less than 10? Yes. That's why it is giving the result as true. At the dollar prompt, for example, if I, sorry, not the dollar prompt, at the Python shell, if you write 2 is greater than 3, it gives the result false. If you write 2 is less than 3, it gives true. That means this is about the greater than operator and this is about the less than operator. Now coming to third one, less than or equals to. If I say 2 is less than or equals to 3, in this case 2 is less than 3 at the same time is equals to 3. No. If any one of the condition is true, the result becomes true. For example, if I write 3 is less than or equals to 3, actually 3 is not less than 3, but it is equals to 3. In this case also, it is going to give the result true. Here we are talking about less than or equals to, here also less than or equals to. If you want to go for greater than or equals to at Python shell, if I write 3 is greater than or equals to 3, in this case, this greater than is not applicable, but equals to is true. In this case, we are going to get the result true. If I say 3 is equals to 3, is the condition is true? Yes, true. Again, the result we are going to obtain is true. For example, 3 not equals to 3. Actually, 3 equals to 3. 3 not equals to 3. Wrong. So, in this case, we are going to get the result false. So, these are the results are the examples for the relational operator. These are very simple. Just one thing you have to remember, that the relational operators or the comparison operators are going to give the result in the form of Boolean values. That means true or false. If operand 1 is less than second operand 2, then it gives true, otherwise it returns false. Like that, you can give any kind of examples. It is a simple example. These are the simple examples for the relational operators. Next, we are going to discuss about the logical operators. Now let us discuss second operators called logical operators. Now we will see how many types of logical operators are there. There are 3 types of logical operators. Now why we are using these logical operators? The main purpose of the logical operators is to combine multiple conditions. Multiple conditions. We will discuss each one with an example. First, we are going to talk about 3 types of logical operators. The first one we are going to discuss is logical AND. It is read as logical AND, but we are using the keyword or the operator AND, A&D AND. And second one is logical OR. It is read as logical OR. It is written as OR. And third one is logical AND. Sorry, logical NOT. It is read as logical NOT. It is written as NOT. First one AND, second one OR, third one is NOT. These are the 3 logical operators. After performing the logical operators, the result again we are going to get is either true or false. But these operators will operate on multiple conditions, right? That we will see with an example. Let us take one example at Python shell. Go to the Python shell. At this place, assume that I am writing the condition 2 is greater than 3. After that, I am writing the logical AND operator A and D. Next here, I am writing 3 is greater than 2. This is the first condition and this is the second condition. What about the first condition here? Evaluate the first condition. Is 2 is greater than 3? No. The result here we are going to get is false. Now evaluate the second condition. 3 is greater than 2? Yes, true. The first one is false and second one is true. See, this AND operator is going to give the result true when the first condition and second condition both are true. When any one of the condition is false, the result is also false. This is very, very important. If 2 conditions are false, the result again false. Only it gives true when both conditions gives true. In any other case, it gives the result false. Now, after performing this, after combining the first condition and second condition, the AND operator is going to give the result as false. This is very, very important. For example, if you apply the same logic, 2 is greater than 3, here I am writing OR, 3 is greater than 2. If you apply OR operator, what happened? The first one is true, first one is false, and second one is true, right? In this case, if any one of the condition is true, then the result we are going to get is true in case of OR. This is very, very important. If any one is true, the result is true. If both are false, the result is false. If both are true, the result is true. But if any one of them is true, the answer is true. This is about OR. Now, for example, if I write NOT operator, for example, here I'm writing NOT in bracket. Here I'm writing 2 is greater than 3 and 3 is greater than 2. See, before this entire expression, I am writing not. So 2 is greater than 3. No, this is false. 3 is greater, this is true. After performing AND operation, the resultant value or the result here we obtained is false, right? Now, before this false, we have not. Then not of false means the reverse of false. The result here we are going to obtain is true. Simply remember that not operator is going to give the negative result. Not of true, false. Not of false, true. This is the use of logical operators. First one we said and second one is or. The third one is not. This is the simple logic of logical operators. Next, we will discuss the remaining. After discussing the logical operators, next we are going to discuss bitwise operators, after that assignment operators. But the important thing you should remember here is, before going to bitwise operators, you should know the concept of number system. Actually, what do you mean by the number system and how many types of number systems are available? These are the basic fundamentals you must understand before moving on to bitwise operators. Let us discuss what actually meant by the number system. See, the number system is mainly used for representing certain quantity. This is very, very important. We are using some numbers, or we can say some measures, to represent the quantity. For example, here I am writing, there are 100 members in the class. See here, the value 100 is the number which representing the quantity or the number of students in a class. That is the main purpose of using the number system. It is only for representing the quantity. Okay. So why we are using the number system? To represent the quantity, right? How many types of number systems are there? Here we are going to have the number systems. The first one is decimal number system. The first one is decimal number system. And second one, binary number system. Next, third one, octal number system. Octal number system. And fourth one we are going to talk about is hexadecimal number system. Hexadecimal number system. Hexadecimal number system. See here, in our daily life, we are using a number system that is called the decimal number system. So whenever we say how many number of students are there in the class, just we have written 100. By default, this 100 comes under decimal number system. What do you mean by dec? Dec represents 10. The base here is 10. Though we are not mentioning the base here 10 as 10, by default, it comes under the decimal number system. Why it is 10? Why? Because the decimal number system is going to have the values from 0 to 9. 0 to 9. 0 to 9, total how many values? 10 values. So that's why the decimal number system is having the base 10. What about the binary number system? When we talk about the binary number system, mainly we are talking about zeros and ones. How many numbers are there in this? Mainly we are using only 0 or 1. That's why the base for the binary number system is 2. We write it as the base 2. For the octal number system, octal means 8. For the octal number system, we are going to use the values from 0 to 7. Total 0 to 7. That's why octal number system is having the base 8. When you go for the hexadecimal number system, here we are going to use the values from 0 to 9. After that, the 10 value represented by A, capital A, B, up to F. A to F. 0 to 9 total how many? 10. A to F how much? 5. So 0 to 9, 10 plus 5. Sorry, A to F 0 to 9, 10. A, B, C, D, A to F 6. So here there are 16 values are there. So that's why the hexadecimal number system is having the base 16. This is very, very important. So finally, what I want to say this is the binary number system or any number system is to represent the quantity. The decimal number system is having the base 10 and the binary number system is having the base 2. Octal number system is having the base 8. Hexadecimal number system is having the base 16. We will see each one with an example, but the important thing you should remember is mainly the decimal number system and the binary number system. And also we can convert a number from one number system into another number system. Let us discuss first the decimal number system. For example, if you take any example, okay, don't take any Python shell. Let us take one example like 676. This is the number. Though you didn't mention any base, it comes under decimal number system. The base is 10. Actually, the number 676 is represented like this: 676. Now, you take the position of 6. 6 is units position. So here we write it as 10 to the power of 0. And here we write 10 to the power of 1. Here we write 10 to the power of 2. Now, when you calculate the result, again we are going to get 676. It is represented like this. This is 6 is in units position, that means 1. It is in 10th position, right? It is in 100th position, right? So now 10 to the power of 0 is 1. Just you multiply 1 into 6, how much? 6 plus 10 to the power of 1, 10. 10 into 7, how much? 70. Plus 10 to the power of 2 is 100 into 6, 600. Now the result we are obtaining is 676. This is the way of representing the decimal number system, right? Now, for example, I want to convert the number 676. This is the decimal number. I want to convert this number into the binary. The base is 2. How to convert the decimal number system into binary, or we can say binary into decimal. These are the basic fundamentals you should know before using the concept of bitwise operators. Now, how to convert 676 into the binary number? Just you take the number 676 and just you divide this with 2. We know 2 3 is 6, 2 3 is 6, 2 8 is 16, the remainder is 0. This is the way of performing the operation. 2 3 is 6, 2 3 is 6, 2 8 is 16, the remainder is 0. Now 2 1 is 2, 2 6 is 12, 2 1 is 2, 2 6 is 12, 2 9 is 18, the result is 0. Just I am performing the division. 2 8 is 16, 2 4 is 8, the result is 1. Okay, 2 4 is 8, 2 2 is 4, the result is 0. 2 2 is 4, 2 1 is 2, the result is 0. Okay, just I am taking the same here. Here 2 10 is 20, the result is 1. 2 5 is 10, the result is 0. 2 2 is 4, the result is 1. 2 1 is 2, the result is 0. 2 1 is not divisible, but you divide with 0 here, the remainder is 1. So what are the values we have? These are the values we write. So how to write the binary equivalent of this? From the bottom you come up. Okay, from the bottom, first you write the value 1 first, next 0, 1 0, 1 0, 1 0 0, 1 double 0. So this is the way of finding the binary equivalent, right? Better to take simple example. For example, instead of taking 676, for example, if you take 12, just simple, 2 6 is 12 is 0, 2 3 is 6 0, right? Simple example here I'm writing. 2 1 is 2 1, just divide with 0 1. When it is not divisible, divide with 0. So the result here 1 1 0 0, right? So the decimal equivalent of, sorry, the binary equivalent of the decimal number 12 is this 1100. Now how to convert this binary number into decimal? In this case, what you do is just you take the binary number like this, and you take the binary number base is 2, right? Now you take 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Now you come from right to left. 2 to the power of 0, 1, 1 into 0, 0, plus 2 to the power of 1, 2, 2 into 0, 0, plus 2 to the power of 2, 4, 4 into 1, 4, plus 8 into 1, 8. Here the result we are going to get is 10. So this is the way of converting the binary equivalent to the decimal. right? Like that, we can convert any number system into any other number system. These are the fundamentals. So in the next session, we are going to discuss the bitwise operators. Okay, with this, I'm going to close the session. Thank you for watching.